Okay. So then, as I said, tonight's lecture is about telecommunication and networking. Every day we used to use networks for, like, I mean, for different methods for communication. For example, using your smartphones, and then using internet, using data, and Wi-Fi networks, uh, wireless data, and I'll say, I mean, cell phone data. We may use like networks from the different ways. Even you may use, for example, Bluetooth, in infrared, for different methods for communication. We're using to share hardware, and to share software, to share data, to access to internet, and so on. And then tonight we wanted to discuss a little bit more details about the telecommunication technologies included in wireless and wirelines and wireless telecommunication networks and technologies, and application of the networks. And then we wanted to turn on to that. We used to use networks for discovery, for communication, for collaboration, and for education. Some of the networks applications are mentioned here on the screen, and we wanted to discuss these applications, fundamental fundamentals of the network and networking technologies. So, first of all, what is a computer network? A computer network includes like more than one computer. If you connect more than one device, like two, three, four, five devices, then you have a network. At least you need two devices to be connected, and then two computers, for example, two laptops, two, like I'd say, like, I mean, one PC and one laptop. And this network can be formed using different technologies, uh, bandwidth, broadband, file server, router, or technologies that we use in networks. And also we have different types of networks. We wanted to discuss these, I mean, terms that we have. LAN is a or local area network. For example, when you are in a campus, when you are in the university's campus, you are using like the local area network of the school. That's like the LAN, local area network. Usually it's within a building. For example, in a business building, in an engineering building. Then we have a local area network. And then if it's more than one building, then it's called like wide area network. If it's more than one buildings, and then it's called wide area network. For example, campus wide. A school's campus wide network is called wide area network. Wide area network. If it's even more, if it's even, I mean, more, includes more buildings and more infrastructures of a city, then it's called metropolitan area network. For example, I mean, TTC, and then GO stations, and then different, like, cities infrastructure are connected through a network, and then this network is called metropolitan area network, MAN, like its abbreviation is MAN. Then so far LAN, MAN, and WAN. LAN is like, I mean, that it within a building. WAN is more than one building, and MAN is like, I mean, more than WAN. In MAN, as I said, in metropolitan network, we have like the city's infrastructure are connected to internet. You may form your personal area network at your home office, for example. Personal area network is a network, or PAN, PAN, is a personal area network at your home office, for example. In your home office, you can connect like your laptop to your desktop, to your TV, to your cell phone, to your printer, to your scanner machine. Does it make sense? All are connected to each other, and then you have a personal area network, or PAN. And finally, at this screen, We have enterprise networks. Enterprise network, which is like the corporate backbone network. So it's here. Let's see, this is, yeah, that's Ethernet local area network, or it's LAN. It's another example of LAN. This graphic shows like a specific type of LAN, which is Ethernet local area network, or like, I mean, it's a LAN, but like it's Ethernet, which is like through a cable, shared cable, and then computers are connected. What we have more in this graphic, we have also, so we have PCs, and then we have a server. We need a server. For like a computer network, we need a server. Server machine is a computer which is stronger. It's storage capacity and processing power is stronger and more than PCs. Like, I mean, the regular PCs that you have. So like it's a server computer in the network, and then we have other hardware systems or machines in a local area network or Ethernet area network. We have also NIC or network interface card. Like, to be able to connect to the network, you need to have an NIC or network interface card, which is a part of your computer device motherboard. And then through that, even like the server has it, and then a printer has that one as well. Another component of the network, which is not mentioned here in this screen, in this slide, is OS network operating system. You need also an operating system for the network. For example, Windows Server. Windows Server is a network operating system, which that, I mean, it's really the same as, for example, Windows on your PC. What's the role of Windows on your PC? It manages everything, like all software, hardware. That's manager of your computer. So, and the network operating system, for example, as I said, Microsoft Network is for managing a network. So the program, like the operating system installed on the server, and then other computers and devices in the network can be connected using network operating system. And also a medium. We need a medium for connection, which is here a cable. Ethernet is a cable network. Make sense? So let's take a look at an enterprise network. Enterprise networks usually include different networks. So we have, like, for example, in a company, in an enterprise, as you can see in this slide on the screen, we have different functions: marketing, finance, human resource, manufacturing, accounting, and like assume that each one is in a building or in a like in a floor, in a part of a building, and then they have their own LAN, local area network. And these, as I said, like these local area networks are connected to each other and form a WAN. Does it make sense? What I said, like one building is a LAN, more than one is a WAN. And then, as you can see here, we have a mainframe. Mainframe is a server computer for your WAN, for your wide area network. And as I said, what's the difference between mainframe and PC? It's stronger. Its capacity for storage is much more than a PC. And then, so then that's the mainframe, and then it's your server. It's your server. So network has different topology or different types. A point-to-point network. Two computers are connected to each other directly, and then they form a point-to-point network. And the second type is BUS. BUS or BUS. As you can see, it's very similar to the Ethernet that we have. Like there is an Ethernet cable here. cable here, and all PCs are connected to each other, and then to the network, and then to the server through these cable. Another topology is again like a cable, or could be wireless, or like it's like a ring. So another type is a star. So what's the difference? For example, if something happens for one of the nodes. So if one of the nodes is disconnected in a ring, the rest of the like computers would be disconnected in a ring. We don't have any ring anymore. So the network is connected. At least a part of the network is done when one of the nodes is done. But like in BIS, so for example, if this computer is failed, if one of the computers failed, then the rest of the network works properly. For the star, we have like the same or like the similar. For the star topology, if one of the systems fails, then the rest of the network can work properly. So we have these three, like four basic types for network topology. And then, as I said, the advantage of this of the star and the BIS comparing with ring is that if one of the nodes is disconnected, one of the nodes fail, then the rest of the network can work and continue working properly. But like as you can see, you need more cables, more mediums, more devices for BIS and star. So Rengi is less expensive, but like as I said, its disadvantage is that if one of them is failed, well, the rest would be failed. So, and then the rest of the topologies that you have here, including tree, mesh, hybrid, all are, combination of the methods that, like the other topologies that we have. Hybrid, in a hybrid, for example, we have BIS, ring, star. In a mesh, we have a network of all connected devices. All are connected. We have like a point-to-point connection. And then all of them are also connect, like one-to-one, point-to-point connection we have in a mesh. And then we have a tree topology also here, which is a hierarchical tree of the connection, So basic concepts, digital signals, along analog signal. Like when I'm talking, when now that I'm talking, my voice is analog. And then what you are hearing is also analog. But like our computer, my computer is converting my analog signals, and even my picture is also, so like the voice, let's talk about the voice. Like the voice is analog. And then like the computer system that we have, that I have, like convert these analog signals into the digital signals, 0, 1 signals, and then 0, 1. And then like transform it to the destinations, to your computers, and again your computer, and again your computer transform this digital signal into the analog signals, and then you can hear my voice. A device, a particular device that converts digital analog signals into this digital signals is modem. Is here a modem? Yes, cable modem. That's a modem. Modem converts analog signals into the digital signals, and then digital signals into the analog signal. So we have another basic concept is a communication medium and channels. We have like here on the screen 3 types of communication media. A twisted pair wire. Twisted pair wire we have here, which this one is twisted pair wire. And coaxial cable, this one is coaxial cable. I said table, no, cable. And then fiber optics. Fiber optics is this one. What is different? Like the speed is very different. Do you know which one is the fastest one for the bandwidth internet communication? Which one has the highest speed? So like that the fiber optics is the fastest one for the, like you can see here, advantages and disadvantages of twisted pair wire, like the telephone cables. Telephone cable is twisted wire, pair wire. And coaxial cable is the TV's antenna. If you have a TV at home, like the TV's antenna is like coaxial cable. And then fiber optics cable. Fiber optics cable, very high bandwidth. As I said, like the internet, the network connection is very fast. It's relatively inexpensive, but like it's difficult to tap. It's security is high. So like it has a lot of advantages. But like as it's like the fiber optics, so like the glasses fiber optics, then difficult to work with, difficult to splice. Twisted pair wire is very inexpensive comparing with other ones. It's the least expensive one. Coaxial cable is also high bandwidth. Well, like its speed is more than twisted pair wire. It's not more than the fiber optics. It's higher than twisted pair wire, and then less susceptible to electromagnetic interferences. It's less. Its security is better than twisted pair wire, while a fiber optics security is even better than coaxial cable. In terms of disadvantages, as you can see, twisted pair wire is slow, and like I mean, it's a high risk. Its security is not very good, and easily tapped, low security. Coaxial cable, it's relatively expensive, not as expensive as uh, uh, it's more than like I mean, it's more expensive than the other options. So, and then its security is medium. Security is between twisted pair wire and fiber optics. So, like because of the advantages of fiber optics, most of the internet service providers are now developing the fiber optics network, and then most of you may have an internet connection at home through a fiber optics cable, or at least coaxial. Okay, when I was a student, like PhD student, it was only twisted pair wire through the telephone network. Well, like these days, most of the service providers in Canada, in North America, is I mean, developing the fiber optics cable network. So another concept that we have is network protocols. Ethernet is a family of wired computer networking technologies, like as I said, wired technology, and like that, it's for local area network, and all of the computers in a network are connected to each other, and also connected to the network through a cable network, and then we have TCP/IP transmission control protocol and internet protocol. How two devices, two computers talking to each other in a network using protocols like transmission control protocol and internet protocol. Packet switching, like 4 layers. Let me explain it in a graphic, for example, here. So when you wanted to send a message from a sender to a receiver computer, first of all, your message is divided. It's a big message, like for example, a graph, a video. First of all, your message is divided into datagrams or packets, divided to packet, a message. It's a message. And it's divided into its big message, and to be able to send it faster in the network. It's divided to datagrams or packets in a network. And then each datagram or packet is datagrams packet. So to send it to the receiver, you need an envelope to put the datagram or packet in an envelope, and then put the receiver, sender, and receiver addresses on the envelope. Addresses of sender and receiver. And then you can send it easier. You can send like the small packets or datagrams easier and faster from sender to the receiver. A protocol for dividing or breaking down a message, an original message to datagrams or packets is called Internet Protocol. Internet Protocol. And then for assigning the addresses. And then for assigning the IP or Internet Protocol. And then for transmission control protocol is for assigning addresses. TCP is for assigning sender and receiver address, and also the sequence of the packets, 1, 2, 3, and 4. And then whenever, like once the receiver receives the packets, they can, assemble the packets or datagrams following the, considering the sequence which is assigned by transmission control protocol. So very simply speaking, we have these two protocols, TCP and IP, to be able, as I said, to divide a message in original message to packets or datagrams, and then sending them, and then assigning addresses, sender and receiver address, and then a sequence, assigning a sequence to the messages, and then whenever receives by the receiver, then the receiver can reassemble the original message. Manages the basic for TCP functions for TCP, as I said, manages the movement from sender to receiver, assigns sequences to the packets, and then reassemble the message. So it's in 4 layers of application, transport, internet, and network interface layer. So, and the message is moving from the sender to receiver from these 4 layers. Let's see graphically here. So, like, this is an original message, as I mentioned already. This is an original message, and then the message is divided into 6 packets or datagrams. When you have like smaller messages, it can move in the internet faster and easier. And then as you can see, message from Calgary to Toronto is, uh, uh, sending using the different paths or roads from Calgary to Regina and then Toronto, and then different roads. And then whenever the message arrived into the Toronto, like the packets or datagrams, the computer receiver, again using Internet TCP or transmission control protocol, they can again reassemble the message. Short video about these. Perfect. So types of network processing, client-server computing, fat or thin, peer-to-peer processing, P2P approaches, accessing unused CPU. So like real-time person-to-person, I mean a collaboration, advanced search, and file sharing, all are like, I mean, the types of processing in a network. And then what's World Wide Web? Internet backbone, intranet, extranet, accessing. So let's define, like, let's take a look at the definitions for these concepts. Internet backbone for Canada, as you can see, in Canada, it's called a canary. Canary is internet backbone, like the fiber optics cable, Canada-wide, coast to coast to coast, as you can see. And then like the red lines show like the internet backbone of the Canada. It's still like, I mean, it's for wire network. Like the lines that you can see, the red lines that you can see show the wire network connecting like the most of the how to say high populated regions of the country. And then the rest of the country is connected to internet using a wireless networks. So like the wired network and internet backbone of Canada, as I said, is Canary. So to access to internet, you have different ways. Connecting through an online service. You can buy an online service for connecting to internet, a satellite connection, connecting through other means like internet kiosks, smartphones, Google Fiber. Maybe most of the people, most of us who are now like connecting to internet is through online services. We're using, like, for example, Rogers, I mean, Bell, the other service providers, internet communication services. Do you know any satellite service in Canada? Any satellite service? Do we have anybody using satellite service, internet? It's growing. It's a growing service. Satellite is also a growing service. It's like area of access, like span of access is more than like the Wi-Fi and then the wired networks, like the cables and so on that they had. It's like from the satellite, and then it could be like the as I said, the span of the coverage is greater than the other methods. Do you know Starlink? Starlink is a satellite internet service provider, and then connecting. You need for connecting connection to the internet through a satellite. You need a dish, and also you need like for now that you are connecting to internet. It could be through your smartphone and data, wireless data. That's like the fastest way, and it's accessible anywhere, anytime. And then another way is like connecting to the internet through a Wi-Fi. For example, we are at home. Most of us now are at home, and then using an internet service provider service. We have internet at home, and then wired or wireless connection to the Wi-Fi network at home. So, and another way, as I said, is satellite access over radio wave satellite networks. For satellite network connection, you need like a dish to receive the waves, like the radio waves from satellite network, uh, uh, radio waves from the satellite, and then the dish is connected to a server, and then like it's connected to a computer, and then you can receive the internet, uh, how to say, like waves. And then for the dish, for so for the Wi-Fi at home, what you need is a modem. And then using a modem at home, you can connect to the service provider's internet service, and then that modem, through that modem, you can connect to internet through a wired or wireless Wi-Fi. Does it make sense? Fiber to the home, like a lot of regions now have fiber to the home or FTTH. Bell, Rogers, they are developing their fiber to the home network. Do you have any questions? Internet protocol IP address. IP address. Can you guess how many devices are now connected to the internet? How many web pages we have? How many websites do we have? So that's very difficult to say how many devices, how many web pages, how many websites, how many home pages we have in the internet. And then we need a system for calling them, for naming. The system is called like Internet Protocol or IP address for domain names. IP address for domain name. Internet Corporation for ESA. So who is managing it? It's like there are uh, different organizations and companies and then consortiums managing the domain names. And like some of them are like the Internet Corporation for Assigned Names, or ICANN has a database. In it, like all of the domain names are a store. For example, if you wanted to start your business, you wanted to assign a name, like for example, mybusiness.com or mybusiness.ca, mybusiness. Like I don't know, or IORG. So I wanted to start my business. So then, like for example, flower.com. So is this name already used by others? If you wanted to assign this name to your website, then you need to check it with ICANN. You need to check it with ICANN. For example, like there are a lot of service providers doing it for you. For example, GoDaddy. GoDaddy is a service provider that they can create a website for you, and then if you want, and then they check the name with the ICANN's database, or like the Internet Corporation for assigned names. So we have different levels for the domain name, and it's called top, like it started from the top level domain name or internet root, and then .com, .edu, .mil, .gov, .org, .ca are top level domains. Second level domains are like, as you can see, dot example, dot morally, and so on. And then we have third level domains. Let's see an example here. For example, dot edu, the university, and then Stanford dot edu, and then Berkeley dot edu, and CS, like customer service. I don't know, like what CS, or maybe what CS stands for what. So, or for example, Amazon.com or Amazon.ca, that's top level domain. And then sales.amazon.ca, that's a second level domain. Does it make sense? Like brocu.ca, top level domain. Uh, mybrocu.ca is the my.brocu.ca is the second level domain. And then even we may have one more uh, uh, level, like the third level domain as well. See if I okay, for example, if I can find a clear example. Would be this one. For example, I found another example graphical for clarification. So I hope that you can see it. Root, that's the internet root. And then top level domain, ed.de.uk.org.edu.com, for example, .ca. And then second level domain, like google.com. That's the second level. Microsoft.com, like I mean, brocu.ca, second level domain. And third level domain, like for example, like I mean, as I said, sales.google.com. That's a third level domain. Does it make sense? Future of internet. What's the future of the internet? It's coming quickly. Three factors could cause internet speed reduction. So the problem is speed, a speed reduction. Why? Because a lot of people are now connecting to the internet. And also like the Internet of Things is coming. Then like a lot of devices like fridges, appliances, uh, uh, industrial machines in the factories, and then for example, gas stations, all are also connecting to the internet. Viewing a full like we wanted to view full motion videos, we wanted to send like the very large, I mean big large files, and then we have big data, we have a lot of, I would say, x-ray images. This I mean sending and receiving these big size files is not easy, and then speed of internet is reducing. Then there is a project for developing a new internet, which is called like the Internet 2. Internet 2. Let's see, as a result, Internet 2 moves data 100 to 1,000 times faster than the old-fashioned internet. Internet 2 is developing, and then 10 gigabits per second and more. 100 or 1,000 times faster than the current internet it will be. Some of the organizations and countries are now developing this internet too, and then in the near future we will have a faster and faster internet. That it's called internet 2, and then in internet 2, like everything is connected to internet. And then we need also another method for domain name system. We need, like, more domain name systems, and then we need a new system for domain name, assigning domain name to the websites, to the things, to the machines, and so on. And then it's changing in the future. What's World Wide Web? It's a system of universally accepted standards for storing, retrieving, formatting, and displaying information via client-server architecture. World Wide Web is based on the client-server network, internet, and then it's being used for sorting, retrieving, formatting, displaying information. There are a lot of applications of the World Wide Web. We wanted to review some of them. So the technologies enabling www or World Wide Web are mentioned here. Hypertext and hyperlink. I wanted to see if it's mentioned here. Yeah, I can mention it easily, quickly to you. Hypertext and hyperlink. So, like, enablers of Word www. So this is a home page, like for example in Brock University, brock.brocku.ca, and then A, and then another home page B, and in it we have a lot of websites, web pages. Does it make sense? Pages, another page. So, and then we have hyperlink to connect one web page to another web page. Hyperlinks, which is called HTML protocol for hypertext markup language. And then through a hyperlink for, connecting a web page from one home page to another home page on another computer in a network, we have another protocol. This protocol, it's called HTTP, Hypertext Transfer Protocol, from one computer to another one, from one page to another page. So then hypertext and hyperlinks are one of the enablers. And then we have websites. Webmaster is a person. Webmaster is a person who manages and maintains, like, the websites. So for example, for website of the brocku.ca website, it has at least one webmaster, maybe even more than one webmasters for different parts of the school's website. Uniform Resource Locator, or URL, is the address of the web pages. Let's see if we have an example of it. Otherwise, I have to show one to you here. Simply speaking, I wanted to show you like examples, but like it's that's like the URL is a uniform resource locator. For example, Brock u.ca is like the URL of the Brock University website. And then browsers. What is the browser that now you are using? My browser that I'm now using for you is Firefox. You may use a different browser now, like for example, Internet Explorer, or you may use, as I said, Firefox, Google Chrome, different. What was another one? Explorer, and so on. So, and then now let's turn onto the network applications for discovery, search engines and meta search engines and portals and publication of material in foreign languages. What type of like the most common search engine is Google's search engine. And then Bing and Yahoo, and then the rest of the search engines. 92.57% of the searches are through Google. Another type of the so, and then portals. What's a portal? Portal is a gateway to the world of the information. So, for example, when you wanted to like general purpose portals or Google, Yahoo, or like I mean public portals. And then we have like for example Brock University portal, which is also a public. A part of it is public, but like if you wanted to access to some information, you need to log in using your authentication information, and then it's a private portal. The other parts are like, for example, list of courses, like I mean, using specific information and also applications, you need to log in, and then that's a private portal. Yeah, we have commercial portals, affinity portals. Affinity is a new customer portal team that provides a modern, more intuitive and clean user interface that allows users to manage their subscriptions seamlessly. Affinity portals, corporate portal, industry-wide portals. So, for example, as I said, like the commercial portal, for example, Google is a commercial portal. Amazon is a commercial portal. Or like corporate portal, like enterprise portals. For example, Toyota.com is like the corporate portal. Industry-wide portal, like for example, I don't know, healthcare portals. If there is, I can't remember any name. Like if you know names, you can share. So we have different types of portals. So as I said, generally speaking, portal is a gateway to the world of information. It could be as for specialized information. It could be for general information like Google and Yahoo. Like for example, if you wanted to access to the hotels booking and flights booking information, for example, Expedia portal, which is a commercial portal as well. You can gain access to the information through these portals. York University Alumni Affinity Portal. This is specific, like I mean, portal for a part of people related to a specific university. So another application of network is for communication. Email, we use it like at not daily, hourly base. Web-based call centers, for example, for call centers, web-based call center, for example, for a call center of Rogers, call center of RBC Bank. You may call them, or like I mean, you may contact them through the websites, web-based call centers, through like through the assistants who are virtual assistants through their websites. Electronic chat rooms, like a lot of electronic chat rooms, like this is the chat room that we are now using through the Teams or like Zoom and so on. Voice communication or internet telephony, unified communications or UC, like unifying all of the communication mediums, and telecommuting. Telecommuting for example, for telework, for telemeetings, for collaboration. So now this, I would say this online class is telecommuting, teleworking and telecommuting in a specific area, which is like the e-education, is online education. Online education is a specific type of applications of web. So what's telecommuting? More details about the telecommuting, like virtual office, working from home. It's for like education, as I said, like for the knowledge workers. What's the knowledge workers? We have like people who are working with knowledge, like for example, engineers, for example, doctors, teachers, lawyers. They are the people who are working with like technicians, like they are knowledge workers who are working with knowledge, and then uh, they can collaborate, meet, and then I mean join teams through internet. And for example, through Teams, through like Zoom, through a lot of other tools for telepresence, for example, for collaboration, and then it's called telecommuting. So advantages is like, I mean, no commuting cost and time. Another advantage is flexibility, convenient, and so on. So what is the disadvantage? Can you give an example of a disadvantage of telecommuting? Working at home. An example. An example of disadvantages of working at from home. No barrier between life and work, like it's boring always being at home, no face-to-face communication with others, less opportunity for promotion as you cannot see like your managers, the other people. And like there are some other even disadvantages associated with work telecommuting. But like I mean less commuting costs, less air pollution, it's more I would say environment friendly. These are the advantages of telecom. And maybe the most important application of network is its application in collaboration for crowdsourcing, using the ideas of a lot of other people. And then for teleconferencing and video conferencing. So for example, designers of a car, designers of a part of a car even, they may work together through teleconferencing and video conferencing while they are living in different countries. Like the system developers, I mean programmers. Programmers are like for Google, for Microsoft. They are working but, together collaboratively to develop the systems, like and then they may are living in a different world, and then like I mean it leads to high levels of the collaboration. It facilitates, actually it facilitates the collaboration, and then uh, like uh, genius would be available. Genius of a lot of people who are living like around the world is available through teleconferencing and video conferencing. For example, for Toyota car design, they can use the designer's genius and knowledge and expertise from the very different countries around the world, people, so they can collaborate in designing the cars, and then it's a valuable source. Another application that you can see here is crowdsourcing. An example of crowdsourcing is like the customer feedbacks. When you wanted to purchase something, you can see the feedback and the opinion of a lot of people who use that when, for example, when you wanted to buy a car, a computer, you can access to the ideas, opinion, and feedback of a lot of people. Crowdsourcing, the more, the better. So then you have more information, more opinions, more feedbacks of people, and then you can make a better and better decision. For collaboration, collaboration is working together for a certain task. It's performed using technologies and processes such as work group, workflow, virtual teams, as I said, like the car designers are working together to design or optimize the design of a part of a car while they are living in different countries virtually. Virtual collaboration, crowdsourcing, and so on. It could be synchronous versus asynchronous. Now our class is a type of collaboration, and it's synchronous. So we may, I for the other course, I may record the lectures and then post it into the uh, course page for the students. That's asynchronous. Email is an example of asynchronous. Does it make sense? Teams meeting is an example of synchronous. This is an example of use of telepresence. Telepresence systems, similar, like as you can see, this is a virtual meeting. Some of the people are virtually yeah, they are in different places. Some of the attendees are virtual. And the last application that we have is e-learning. E-learning uh, and then e-learning supported by the web. So it has very different types. Even we have now virtual universities, virtual colleges. A lot of uh, lectures and materials are recorded and available through internet. So virtual university, can you give an example of a virtual university? Do you know any virtual college, virtual university? Responding and I can see. No reaction. That's okay. So for example, Khan Academy is an example, and a lot of other, so uh, colleges, schools, universities, a lot of material available through the internet, through even through the through YouTube. A lot of, material are available and people can use them. It could be synchronous and face to face. It could be like, virtual, or it could be asynchronous. So do you have any questions? So if you don't have any questions, let's play a game quickly and then we can conclude the meeting. information.